Namaskar. Dear students, we are aware about the gradient of scalar function, how to find the gradient. This is one example that we have already discussed. Then we are aware about the divergence of a vector function, that means del dot a bar. Suppose this is a vector function, then how to find the divergence of the vector function. And also we are aware about the curl of a vector function, that means del cross a bar, that means how to find the curl of a vector function. We have gone through the physical significance of divergence, gradient and curl. Now in this video we will have to discuss the fundamental theorems for gradient, divergence and curl. Now with the background of how to find the gradient, how to find the divergence and how to find the curl, and what is the meaning of line integral and how to find the line integral of a function, what is the meaning of surface integral and how to find the surface integral of a function, and what is the meaning of volume integral and how to find the volume integral. We are aware about all those things, that means the gradient, divergence, curl and line integral, surface integral and volume integral. With this background, I would like to introduce three fundamental theorems which relates the integrals with help of the gradient, curl or divergence. Now we are aware about the derivative and integration. They are complement to each other, and therefore we can say that suppose if I think about a derivative of a function df by dx, and then if we integrate it from certain limit, that is a to b over dx, then this is nothing but the difference between the functional values at b and at a. Therefore we can write the integration from a to b of df by dx over dx is equal to f of b minus f of a. Now with some function, say for example f of x is equal to 3x square and the point a to be equal to 1 0 1 and b to be equal to say 2 1 3. You can check this. What you will have to do? You will have to find the derivative of this. Then again see, this is derivative, then you will have to integrate this. This will be the left hand side, and then you will have to substitute the values. Oh, actually there is no need of 3 coordinate. Just I can say that a is equal to 1 and b is equal to 2 here, or for any two values. You can think about that. You will have to integrate from a to b, that means from x is equal to 1 to x is equal to 2, and then find the difference between the functional values at b and at a. If I will have to extend the same thing for the 3 dimension, correct, for the 3 dimension, then what I will have to do, instead of the derivative I will have to consider the 3-dimensional derivative, that means with respect to x, with respect to y and with respect to z, and that is nothing but the gradient of the function. We are aware about the vector derivative, it is gradient of f, and instead of the integration over x only, now there is a possibility of change in x, y and z, all the 3 coordinates, and therefore I will have to integrate over dl, which is a vector term. Therefore here I will have to consider a dot, and then I will have to integrate from a to b, and again this is nothing but f at b minus f at a. Now this is known as the fundamental theorem for gradient. Now you are aware about how to find a gradient of a scalar function. You are aware about how to find the line integral from a certain point a to point b. Now here we will have to consider the coordinates with all 3 variables, that is x, y and z. Means you can find the left hand side of this. Similarly you can substitute the value of for x, y, z for b in the function, similarly for a, and you can find the difference and you can find the right hand side, and you can check the validity of fundamental theorem for gradient. For that let we will use the function f to be equal to our traditional function, say for example, or any function. It is 2x square y minus yz cube, say for example, plus 3. Now this can be treated as the function for testing of the fundamental theorem for gradient. Let the point A be 1 0 1, that the point which we have just considered, and point B to be equal to, say for example, it is 2 1 3. Okay, therefore now homework for you. What you will have to do, you will have to test the validity of fundamental theorem for gradient with the function f given by this and point A and point B. In next video I will give you the solution of this so that you can check whether you have done properly or not. Similar to this, one more relation is there between the volume integral and surface integral. And for that, I will have to think about the divergence of A bar. The divergence of A bar is the scalar quantity, and therefore I cannot integrate it with line or surface because these two are the vector quantities, but I will have to integrate it over the volume. Therefore it is volume integral of divergence of A bar over the volume is equal to closed surface integral of A bar dot ds bar. Now we are aware about how to find a surface integral over a particular surface. And now here what we will have to do, we will have to consider all the surfaces which encloses that volume. I will let you know how to find this. And this theorem is known as the fundamental theorem for divergence. Now for a homework, I will give you the function A bar to be equal to, it is x square z I cap minus 2y j cap plus x cube k cap. This is any function. Now you may think about your own function also, no issue. And now what we need? We need the closed surface which bounds the volume. Now for simplicity, we will assume the Cartesian coordinate system because the integration will be easy and we are aware about such type of integrals. This is our x-axis, this is the y-axis, and this is z-axis. We shall assume a rectangular box of length L, say for example 3 unit, then the width, say for example 2 unit, and a height of 2 unit again. Therefore this will be the rectangular box, correct? This is our box. Now when we think about this box, it has certain volume, okay, with length to be 3, breadth to be 2, and height to be 2. Therefore if we will have to integrate over the volume, we are aware how to integrate. Means what we will have to do, first of all we will have to find the divergence of A, or this, it will be the scalar quantity. Then we will have to integrate over the volume, over x from 0 to 3, over y from 0 to 2, and over z from 0 to 2 to cover this entire volume, and that will be the left hand side of your solution. For the right hand side, what we will have to consider? We will have to consider the surface which encloses this volume. And in this case, it is not the single surface, but on the other hand, it is better to have splitting of this surface which encloses the volume into 6 different surfaces: top surface, bottom surface, right surface, left surface, back surface, and front surface. And therefore what you will have to do, you will have to consider 6 open surface integrals. These surfaces are open, but if I add all these integrals, then effectively it is closed surface integral of A bar dot ds, where this surface integral is over all those 6 surfaces which encloses the volume. Means what you will have to do, you will have to calculate 6 open integrals for top, bottom, right, left, back and front surface. Add them together. This will be your right hand side, and you will have to check that the left hand side and the right hand side, the values are same. Okay. Exactly in the similar manner, we may think about the third theorem which relates the surface integral and line integral. That means obviously if I think about a surface, it is bounded by the line, and therefore here I can say that. See, in case of the volume integral, this was the volume integral. Volume is bounded by the surface. Similarly, surface is bounded by the line. And here the theorem is curl of a bar dot ds bar is equal to a bar dot dl bar, closed line integral. That means surface integral of curl over the surface ds, that means over the surface, is equal to the closed line integral of a bar dot dl bar. Again, we are aware about how to find the surface integral. We are aware about how to find the line integral. And for simplicity, we will consider the function a bar to be equal to, let the same function, x square z I cap minus 2y j cap plus x cube k cap. But for this, for the fundamental theorem of curl, to check validity of fundamental theorem of curl, we need the surface. And we will assume the surface something like this. This is our surface. Okay. It is at x is equal to 3, say for example, with a height. So therefore the coordinate of this point is also 3, and this is 5, say for example 3, 5, 0. And this point is in xz plane, which is at 3, y 0, and let z is equal to 2. Therefore this is 3, 0, 0, and coordinates of this point, along x axis it is 3, along y axis it is 5, and along z axis it is 2. Therefore this is our surface, and this surface is at x is equal to 3. Correct? This is at x is equal to 3. Now what we will have to do? To find the left hand side, we will have to find the curl of this vector function and then integrate over this surface. Correct? This surface. For that, we will have to keep x to be constant, it is 3, y to be changed from 0 to 5, and z to be changed from 0 to 2. You are aware about how to calculate such type of surface integral. For the right hand side, it is closed line integral. Therefore, the line which encloses this surface, and you will find that there are 4 line segments which forms the closed line to bound this surface. And therefore, what we will have to do? We will have to integrate over a line from this point to this point where there is change in y only, x and z remains constant. Then from this to this where there is change in z only, x and y remains constant. From this to this, again there is change in y, and from this to this, again there is change in z. For all the segments, x is equal to constant, it is 3. Then we will have to add all those integrals, 4 integrals, and that will be the closed line integral of a bar dot dl bar. Now you will have to check whether the left hand side and right hand side are same. In the next video, we will prove that all the theorems are valid. Obviously they are valid, but for homework you may begin with this. It is fundamental theorem for calculus, this is fundamental theorem for gradient, this is fundamental theorem for divergence, and this is fundamental theorem for curl. Thank you.